Why does a flat rectangular USB plug never go in the first time? It only fits one way up, and nothing on the outside of it reliably tells you which. So you push, you turn it over, and you push again. That plug is still on the car dashboard, the hotel nightstand, the arm of an airline seat, and the back of the desktop computer. Always the same flat rectangle. Those plugs are all the same shape because of a single document. That document is a specification. A specification is the written rules for how a thing has to be built, agreed by the companies that build it. People also call it the standard. The USB one turned 30 years old this January. In April this year, European law made a working USB-C port compulsory on new laptops sold in Europe. USB-C is the newer, smaller connector, the one that goes in either way up. The rectangle is still on the side of the machine. So this is where it came from. It started with a small group of engineers at Intel, and they made that plug fit one way on purpose. This is who they were and why they did it. It is also how the plug ended up on almost everything you own, and what it finally took to get one you can put in either way round. The one-way plug was not an oversight. It was a price, argued over in a room, and written into a document you can still download. The early 90s. Ajay Bhatt is a computer architect at Intel. A computer architect decides how the parts of a computer talk to each other. It is a job about the plan, not about building any one piece. At home, there is a family computer that his wife and daughter use now and then to type things up. One day, his daughter writes a paper for school and wants to print it. Bhatt is at work. His daughter and his wife spend the entire day failing to get a single page out of that machine. He has told the story many times, and his wife's verdict never changes. "Thing about my wife is she puts up with no nonsense," he said this summer. "She says we have all these things and it never works. What good is this?" So he goes and looks properly at the way the whole machine is put together. I thought, there are better ways of working with computers, and this is just too difficult. What Bhatt wanted was one kind of socket that every device could plug into, with a single shared set of wires running behind it. Engineers call a shared set of wires like that a bus. It is the B in USB. The U and the S are universal and serial, anything can plug in, and the information goes down the wire one piece at a time. He wrote it up as a proposal and took it to his own group at Intel. It did not go well. "When I showed it to people, there was not many takers for this," he said. "Basically, I was asked to just give up." He did not give up. He moved to a different research group inside Intel, took the same idea to a new manager, and asked again. The answer he got was not a yes. "Ajay, I don't know whether you'll succeed or not, but you know what? Go convince yourself." Bhatt's comment on that decades later, I took that as a yes. Buying a scanner in the early 90s went like this. You took the lid off your computer and pushed a card into a slot inside it. The scanner would not work without that card, because nothing on the outside of the machine could talk to it. Then you set the card up by hand. It had rows of tiny switches and small plastic clips called jumpers that you pushed onto pairs of metal pins. Those settings told the computer two things: which internal channel the card would move its data on, and which line it would use to get the computer's attention. Every card in the machine needed its own channel and its own line. Pick a channel or a line that something else was already using, and neither device worked. There was no way to know in advance, so people worked through it by trial and error. Close the case, power on, and find out. Usually it did not work, so you powered down, moved a jumper, and did the whole thing again. You can measure how often that failed, because a shop counted it. CompUSA, one of the big American computer chains, reported that about a third of the scanners it sold came back. Its entire scanner business ran at a loss. That is the problem USB was built for, not a slow bus, a shop full of returned boxes. A year and a half into the work, Bhatt goes to a meeting at Microsoft. On its own, a new kind of socket is worth nothing. It only becomes real if the big computer companies agree to fit it, and Microsoft is the first he asks. He gives the Intel marketing man traveling with him exactly one instruction: introduce me, and then stop. At the whiteboard, he shows them where the thinking has got to and makes the offer. Join now as a founding member while the design is still open, and you help decide what it becomes. Microsoft's answer, in his telling, "This is the best technology proposal that we've seen so far, and we would love to join you." Bhatt does not want to stop at Microsoft. He wants the idea judged from 3 different sides: as hardware, as software, and as a thing a person has to plug in. With Microsoft in, there are 2 companies behind the idea instead of 1. The group goes to the others and invites them to join. IBM, Compaq, Hewlett-Packard, Digital Equipment. And Microsoft brings a mouse. Microsoft made mice. A mouse was the most common thing anyone plugged into a computer at the time, so the group designed around it. If the new socket could not suit a mouse, it could not suit anything. Then Microsoft gave the group a number. The entire electronics budget for its mouse, every chip and component inside the shell, was 50 cents. Whatever USB added to a mouse had to come out of that budget. Jim Pappas was one of the Intel engineers on the project. He told Microsoft that USB would need to move at least 5 megabits a second, even out of something as simple as a mouse. A megabit a second is a measure of speed, how much information a wire can carry each second. Betsy Kim ran the engineering on Microsoft's mouse team, and she told Pappas what that speed would cost. At that speed, a mouse cable would have to be shielded. A shielded cable has a layer of fine metal braid wrapped around the wires inside it, so that they neither pick up interference nor give any off. Braid costs money. Shielding ran about 4 cents a foot. A mouse cable is 6 feet long, 24 cents on a budget of 50. That made the mouse too expensive to compete, and for Microsoft it was a deal breaker. So the group gave USB a second speed, a slower one, running alongside the fast one. 1.5 megabits and 12 megabits. The slow one was slow enough to run on plain unshielded cable, which is what cheap devices got. Everything else got the fast one. 12 megabits, well past the 5 Pappas had asked for. The mouse could sit on the slow one, with no shielding at all, and stay inside its 50 cents. That one decision, taken to keep a mouse cheap, set the cost of everything USB did afterwards. The decision to save the mouse grounded our cost structure, Pappas said. I think it was one of the most important decisions we ever made. The mouse was one cost wall, outside the machine. The second was inside the computer, and it was measured in space rather than cents. Every USB socket needs something inside the computer to run it. That part is called the controller, and it does the talking on the computer's end of the cable. Intel wanted to put that controller into its chipset. A chipset is the group of support chips sitting on a computer's main board, and its job is to connect everything to everything else. The condition was that the next chipset had to sell for the same price as the last one. Extra circuitry takes up space on a chip, and space costs money. So there was a hard limit on how big USB was allowed to be. A chip is built out of tiny switches called gates. Each gate does a single yes or no piece of work, and the size of a design is counted in how many of them it needs. Bala Kadambi managed the USB development team. The most liberal budget we were allowed, he said, was 10,000 gates on a chip. That was the whole allowance, for a bus that had to run keyboards, printers, scanners, cameras, and, in Kadambi's phrase, as yet uninvented peripherals. Under those two limits, the connector got 4 contacts and no more. 4 metal pins in the plug, 4 wires in the cable behind it, and nothing spare. 1 wire carries power. 2 of them carry the data. The 4th is the ground, which is the return path that any electrical circuit needs before it will work at all. Now turn that plug over in your hand. The order of the 4 reverses so the power pin ends up where the ground pin was, and nothing lands where it is supposed to. So a plug that goes in either way up needs a second set of contacts, mirrored, so that one set always lands correctly whichever way round it is. Double the wires, double the circuitry at both ends, and about twice the cost of the part. The rectangle was a deliberate choice too. A round plug was considered and rejected, because a rectangle gives you only 2 ways to try it, while a round one can be presented at any angle at all. Years later, an interviewer asked Bhatt about the plug that goes in one way. The biggest annoyance is reversibility, he told NPR. In hindsight, based on all the experiences that we all had, of course it was not as easy as it should be. So the plug fits one way. Making it fit both ways meant doubling the parts, and doubling anything was the one move this project could not make. The USB cable carried power as well as data. No widely used computer port at the time supplied it. A USB device could run off the 4 wires alone, with no card to fit inside the machine and no jumpers to set. There was a limit on how much of that power the cable would hand over. A watt is a measure of how much electricity a device draws, and the budget for whatever was on the far end was about 2.5 watts. Not much. Logitech was building a prototype portable scanner, the kind you feed a page through, and it needed more than the cable would give. The standard did not move. So the company went back and built the machine again, new motors included. September 1995. The Fairmont Hotel in San Jose, where USB is about to be shown to the computer industry for the first time. About 700 people. One of the engineers there remembers standing room only. Pappas is the Intel engineer from the argument about the mouse. When he is introduced, he comes to the stage from the back of the room, dragging a bundle of cables behind him with mice and keyboards still attached. He gets to the front and says that all of this can be replaced by just one of these. Then he holds up a single rectangular plug. January 1996. The rules everyone had been arguing about are finally published as a document. It is revision 1.0 of the Universal Serial Bus Specification, and 7 companies are named on the cover, Intel and Microsoft among them. Getting there had meant saying no. Once it was clear USB was going to happen, every company wanted its own feature written into it. The requests on record include cable runs of up to a kilometer and waterproof connectors for underwater dive computers. We sometimes talked about the Christmas tree effect, Papa said. Everyone felt that if they could add their favorite ornament, the tree would be perfect. But at some point, the branches droop and the tree falls down. What did survive is written down in extraordinary detail. The document recommends that the plastic shell of the plug be frost white. It requires the connector to survive being pushed in and pulled out 1,500 times. And it asks for the USB icon, the little 3-pronged symbol on the plug, to be molded into the plastic inside a shallow dip a fraction of a millimeter deep. The reason, in the standard's own words, is so that there is a perceptible feel of the icon, a mark you could find in the dark written in from the beginning. You can feel the mark. It still does not tell you which way up to push the plug in. The 1996 document never says which way up any of that goes. It does not say which face of the plug the icon belongs on. And it says nothing at all about which way round a socket should be fitted into a machine. There is a later version of the specification, dated 1998, and it writes both of those down. The icon belongs on the top side of the plug, and the standard makes it required there. Sockets should be fitted so that the icon on the plug ends up facing you, where you can see it at the moment you push the plug in. One of those two is required, the other one is a should. In a document like this, required means you must. Should means you are being asked nicely. The mark on the plug is the required one, and the plug is the half you are holding and can look at. Turning the socket the right way round is only a should, and a socket lives on the back of a desk or on the arm of an airline seat in the dark. All of it is in the standard, and you still turn the plug over? Publishing a standard does not make anyone use it. Somebody still has to decide to build the thing, and that usually costs money. Normally, if you build something covered by another company's patent, you pay that company for permission. The payment is called a royalty, and it is charged on every unit you sell. USB cost the companies building it nothing in royalties. One document made that work. It was called the Adopters Agreement, and any company was free to sign it. Sign it, and every other company that has signed gives you a free license to the patents you need to build USB. The price is the same license back. You let all of them use yours. No company can then sue another over a patent that USB needs, because everyone has already given everyone else permission. Nobody pays anybody. USB was not the best bus of its generation. In several respects, the best one was the standard Apple sold as FireWire. It carried more power and it ran faster on the day it launched. It also did not need a computer in charge of it. 2 FireWire devices could talk to each other directly, where USB always needed a computer sitting in the middle. On the engineering, FireWire won. Then, in January 1999, Apple went to PC makers and asked for a royalty on it, about $1 per port charged for every FireWire socket a manufacturer fitted. The chips themselves cost under $5. Industry sources at the time called the rate unreasonable, and Intel is reported to have gone to Apple's senior management to protest. Apple revised the figure downward within months. By then, the comparison had already been made. Intel, meanwhile, was building the USB controller into its own chipsets. The part that ran the port was already in the machine, already paid for. For a PC maker, adding USB cost little more than the price of 2 connectors. The better bus lost to the cheaper one. It lost on $1. A patent covering the core of USB lists 8 inventors, and Bhatt is the 4th name on it. The patent itself belongs to Intel Corporation, and not to any of the people named on it. That was normal. He was an Intel employee, and an invention made on the job belonged to the employer. Bhatt has never earned a royalty on USB. In 2009, Intel ran an advertising campaign built on the idea that its rockstars are not like your rockstars. In the advert, staff mobbed the inventor of USB in the company cafeteria. The man they are mobbing is not Bhatt, he is an actor. We were not worried about notoriety, Bhatt told NPR. In the end, it's a team sport. My feeling is that if everyone adopts your idea, then you've succeeded. Notoriety should be given to the technology. Around the time the advertisement ran, One of his siblings handed his father an article about USB. His father was a professor, and he was the one who had sent his son to America to get a doctorate, the highest degree a university gives. Bhatt never got one. He kept changing jobs, and his father had never quite understood what he did. The old man read the article, then rang his son. "You know what? When I read this, you've done some amazing things, and I never realized." Revision 1.0 does not name a single person who worked on it, and neither does the version after it. The first USB specification to print the names of the people who built it is USB 2.0 4 years on. Later still, one name arrives on its own at the very front of a later revision. It is not Bhatt's. Brad Hosler was an engineering manager at Intel. Dedicated to the memory of Brad Hosler, the impact of whose accomplishments made the Universal Serial Bus one of the most successful technology innovations of the personal computer era. The dedication does not say what those accomplishments were. Since revision 3.0, the specification has opened with it, and it is still there in the current one. For years, the people who built this thing went unnamed in their own document, and the first thing the current specification says is a dead man's name. The connector shrank twice before it changed, mini, then micro, and both of them still went in one way up. Then, in August 2014, the specification for a new connector arrived, and this one went in either way up. It is called Type-C, and it is the one on phones and new laptops now. It came out of the USB 3.0 promoter group. A promoter group is the small set of companies that actually writes a standard, rather than the many that later sign up to use it. 6 companies, and Apple was not one of them. The current version of the specification lists Apple's name in that group's copyright line, the list of company names printed at the front of the document. The company that charged $1 a port for the rival bus is inside the group now. That old rectangle, the connector the specification calls Type A, has 4 pins. Type C has 24 pins mirrored top and bottom, so whichever way round you push it in, every contact meets the one it was meant to meet. Making a plug work both ways up was never impossible. For the rectangle, it would have been double the wires. For this connector, it was 6 times as many pins. Before Europe made USB-C compulsory, it asked. In 2009, at the European Commission's request, the big phone makers signed a voluntary memorandum to converge on micro USB charging. Apple, Nokia, and Samsung all signed it. A memorandum like that is a promise between companies rather than a law. Nobody is fined for breaking one. They were agreeing to settle on the same charging plug. It half worked. The number of different ways to charge a phone in Europe fell from about 30 down to 3. The promise allowed adapters, so a company could sign it and keep its own socket as well. Then the agreement expired and nothing replaced it. So the Commission stopped asking. Europe wrote the requirement into law instead in what is called the Common Charger Directive. A directive is a European law that every member country has to write into its own rulebook. This one did not start from scratch. It added a single new requirement to the rules Europe already had for radio equipment, the rulebook these devices already sat under. From the end of 2024, a named list of devices sold in Europe had to carry a working USB-C socket. Phones and headphones were on that list, laptops were not. Laptops got their own deadline, more than a year later in April 2026. The law worked, in the sense it was meant to. New laptops sold in Europe carry a USB-C port, and one charger now does the phone, the tablet, and the headphones as well. It did not remove the rectangle. The directive requires the USB-C socket to be present and working. It does not ban any other socket. A laptop sold in Europe today can still carry a barrel jack, the round socket an old power brick plugs into. It can carry 3 of the old rectangular ports as well. It only has to charge properly over USB-C too. The document that defined the rectangle is 30 years old. Today's specification calls the rectangle the legacy connector, and then carries on supporting it. Legacy is the word a standard uses for the old thing it has moved past and has not thrown away. USB 4, the newest generation of the standard, cannot run over the rectangle at all, officially superseded and still shipping. Somewhere in the room you are in, there is a rectangle with 4 contacts inside it. It fits one way because a second set of contacts would have cost money, in a project where cost settled almost every argument. It is still there because everything else was built on top of it. The standard moved on. The rectangle never had to, so it did not. Consider liking and subscribing for more load-bearing history videos.